Hi everyone, welcome to the session. In this session, we focus on two major contributions: Buddhist architecture with its stuvas and viharas, and the magnificent traditions of temple architecture and rock-cut architecture. And we will analyze about how did engineering thinking evolve alongside cultural and religious needs. The diversity and technological skill crystallize in the great tradition of Buddhist architecture. Let's start with the stupa, a hemispherical mound for relics. Its components are symbolic and structural. The anda, the dome; the methi, the elevated base; the hamiga, a railing at the summit; and Chataravali, a series of umbrellas. Look at the great stupa at Sanchi. Its solid earthen core is faced with stone and is surrounded by beautifully carved gateways called toranas. The engineering had to ensure stability for this large earth and stone mound. Its primary use was for ritual circumambulation, meaning pradakshina, meaning its design was as much about guiding human movement and experience as it was about structural integrity. For the monastic community, the vihara or monastery was essential. They began as simple cells around a courtyard but evolved into vast complexes with halls, shrines, and libraries. The engineering challenge here was about planned living spaces and community design, but the most astounding examples are rock-cut viharas like those at Ajanta and Karli. Imagine, instead of building up, you carve down and into a solid rock cliff. This requires inverse engineering, visualizing the finished space inside the raw stone and excavating with precision to create pillars, rooms, and ceilings without collapse. It's a breathtaking feat of spatial planning and stonework. This expertise in stone and symbolism reaches its zenith in the temple architecture of India. Early forms were circular or apsidal, using brick and timber, but the classical styles are iconic. The Nagara style of North India with its beehive-like curvilinear shikara. Then the Dravidian style of South India with its stepped pyramidal vimana and colossal entrance gopurams. The Vaishara or hybrid style in the Deccan. Temples are complex organisms. Mandabas, pradakshina paths for circulation, and incredibly ornate carvings. The engineering was now fully married to a symbolic geometry where every proportion was meant to represent the cosmos and facilitate the journey from the mundane to the divine. If temple building is a feat, then rock-cut architecture is a miracle. These are structures carved directly from living rock masses. Early examples are the Buddhist Chaitya halls and viharas at Ajanta and Kali. Later the ambition becomes almost unimaginable. At Ellora the Kailasa temple isn't built. It is a single giant megalith sculpted from the top down out of a hillside, mimicking a free-standing temple complex. Similarly, the Pancharathas at Mahabalipuram are monolithic temples, each carved from a single boulder. They required engineering skills, precision carving, profound understanding of structural integrity and load distribution in rock, and masterful spatial planning. It represents the ultimate confidence in manipulating the physical environment. Let's pause and synthesize. This table brings our chronological journey into sharp focus, from adaptation in the prehistoric era to urban systems in Harappa to sacred geometry in the Vedic age. We see masonry evolve in the post-Vedic period, monumental scale in Buddhist architecture, symbolic stone carving in temples, and the peak of rock manipulation in cave temples. Each period builds on the knowledge of the last, adding new layers of technological and conceptual sophistication. To conclude, the evolution of architecture in ancient India is a mirror to its changing religious, cultural, and social fabric. We traced a path from functional shelters to monumental religious complexes. What stands out is the deep, inseparable integration of engineering, science, and symbolism. The Solvasutra's geometry, the hydraulic genius of Harappa, the rock-defying courage of Ellora all speak to civilization that applied its understanding of physics and mathematics to create spaces that were both physically enduring and spiritually profound. This legacy of planning, design, and exquisite craftsmanship is not just history, it's a foundational chapter in the story of human ingenuity. That's all for this session. Thank you.